Here we go. We have a question equilibrium point. So you have given an array of non-negative numbers. Our task is to find the first equilibrium point. The equilibrium point in an array is an index such that sum of all the elements before that index is same as sum of elements after it. And if there is no point exist, we need to return -1. So we have this array and this is the equilibrium point. So the element on the left hand side, the summation is 3, and the summation on the right hand side is also 3. So the index, the equilibrium point is 2. In this case, if we take this, the left summation is 0, right summation is 3. If we take this, left summation is 1, right summation is 2. If we take this, left summation is 2, right is 1. If we take this, left summation is 3, right is 0. So we don't have any equilibrium point. That's why we need to return -1. In this case, we have answer as 3. So 0, 1, 2 and 3. So the elements, uh, actually it is given that we have non-negative numbers, but here we are taking negative numbers, and in the constraint we also have given we don't have negative numbers. So I don't know whether this case is a valid one or not. Anyway, so 0, 1, 2 and 3. So the element on the left hand side, the summation is -1, and the summation on the right hand side is also -1. So the index is 3. Now let's build the approach. I hope you already got this. First, to find the summation on the right hand side, what we'll do, we will take a variable as summation. So let's take a summation variable and let's found the summation. So 10, 20, 30, 37, 47, 67. So the summation is 67. So if there are more than one equilibrium point, we need to return the first one. So let's first this point as our equilibrium point. So we need to subtract this number. So the element on the right hand side is 62 and the element on the left hand side is 0. So it is not equal. Let's pick the next point as our equilibrium point, but we need to consider this point on our left. So consider this point and remove this point. So we have 60. So this is not also not equal. Next we will pick this and we will add the number here and remove 3 from this. So we got 57. It is also not equal. Let's pick the next equilibrium point, 10. So value here is 17 and we need to subtract 10. So we got this. So this is also not equal. Let's pick 2. So we have, actually I think I have made a mistake here. So we have 7 till now, and we have subtracted 57. So we have subtracted 10. So let's find out whether this is valid. So 30, 37, then 40, 47. So we have 47 here. Value here is 47 and value here is 10. So is this a valid one? No. Let's check for the next number. But we have to include this number here and subtract this number here. So we have 45. So this is also not valid. Let's pick the next number, 3. But we have to include 2 and we have to decrement 3. So we have 42. So this is also not valid. Let's pick the next number. We have this 5. So we need to include this number. We have 25 and we have to subtract this number. We have 37. So this is also not valid. Let's consider the next number. So we have this. So we got 30 and we need to subtract this number. So we got 30. So this is our equilibrium point. So we will return the index. So this question is pretty simple. Let's code this. We have n long, we have sum as long. So first find the summation and just iterate. So just decrement this element, and if the value on the left hand side is equal to elements on the right hand side, return the index. Else consider that index for our next iteration. If it does not find any equilibrium point, just return -1. So I hope this will work. Let's discuss about the time and space complexity. So we have a simple for loop. So the time complexity will be order of n, space is constant. We have met the expected time and space complexity. Thank you all for watching this video.